So in the last class, we talked about the tangent line, but I never really spoke about like exactly what the tangent was. So let me just quickly go through that. This is a combination of stuff you learned like in ninth grade, 10th grade. Actually, it was ninth grade, but let's bring it together. So the question is, uh, let me get this right. So like aim, like first thing is the first thing is tangent line, and then the other part is first principles. First principles. Okay, so what is a tangent line? So you know the tangent line as you remember it as like sine over like opposite over adjacent, and then maybe you did like sine over cosine, like that's what you did, and then you learned some stuff. The other thing you learn about a tangent is from the geometry unit, and that's a line. So in the geometry, you learn a line that just touches the circle in one point. In this class, a tangent we saw from yesterday was a line that touched the curve in one point. Let me just deal with that for a second. So we had our cubic yesterday, right? And we had like the tangent line right here. And so it touched it right here. Someone might say, "Hey, Mr. Adler, that tangent line touches it again up here." True. So let's make a modification of the definition of what a tangent line is. It's a line that touches a curve only at one point locally. So if I zoom in here, like if I get really, really close, like take a microscope to this point, the tangent line only touches the curve, intersects the curve at one point. You also recall from your geometry days that a line that passes through a circle at 2 points is known as a secant. So we're going to need that word. Okay, but I want to connect these two. Like, how is the tangent that we know sine over cosine, and the same idea that it touches the circle at one point? Well, let's do this quick. I'm going to put the graph up. Up, stop. Okay. Hold on, so let me cut that back. Oh, did I lose that? Oh, there we go. Oh, it erased it? Okay, anyway, so you can just go back to the video. Anyway, so how do we connect? So I'm going to put the graph, I'm going to put the grid up, rectangular grid. And then what I'm going to do is I'm going to put a circle over here, okay? And so then I'm going to draw in, whoops, let me get off that circle. And what we did was let's see. And so what we did was we had this triangle here, right? And this length was 1, and this was sine. No. This was cosine, and this was sine, right? And so the idea is that we extend this line. So let me change the color. No. Let's change the color to, let's make it light blue. And what I'm going to do is I'm going to extend this out. Sorry. I'm going to extend this out, up and then down, so perfectly comes there. So the next question is, what is this height? Let's call it, I don't know, T. So what we have here are we have two similar triangles. We have the small black and the big blue. So we know that the ratio of corresponding sides is in proportion. So I'm going to say sine over cosine so it's sine theta over cosine theta is equal to what? T, which I don't know is T, over what's this length here? Oh, that's 1. And so it turns out that this height is actually tangent, which is sine over cosine, and it's an actual tangent to the circle. So that's the connection. This is an actual tangent. This length is tangent, but it's an actual tangent to the circle, and that's the connection between the tangent that you know in geometry to the tangent that you know from geometry. Trigonometry. Anyway, I'm going to end this video now because it's out of control. Anyway, let's get up and and that's it. Sorry. How do I shut this off?